In this video, we're going to find the values of trigonometric functions of acute angles. So let's find the values of each of the 6 trigonometric functions of the angle theta in the figure. Let's start by using the Pythagorean theorem to find the missing side of our right triangle. They tell us that in our figure here, there's our angle theta. Side A is going to be 21. Side B is going to be 20. A squared plus B squared is going to be C squared. And so this is 441 is C squared. And so that's going to be 841 is C squared. And then C is going to be 29. Let me just show you that. 29 times 29, that's 81. 18 and 8 is 26. It's another 18. 4 and 1 is 5. That's 841. So this is a special right triangle. It's one of the less popular special right triangles, but it's a 20, 21, 29, where all 3 sides are integers. This is called a Pythagorean triple. We'll deal with several of those throughout our trigonometry portions here. So you might want to remember this one. Some other ones worth remembering are 3, 4, 5, 5, 12, 13, 7, 24, 25, and 8, 15, 17. The book is going to use those a lot. Let's go ahead though and fill this in here. And sine is going to be opposite over hypotenuse. Cosine is going to be adjacent over hypotenuse. Tangent is going to be opposite over adjacent. Cosecant is going to be hypotenuse over opposite. Secant is going to be hypotenuse over adjacent. And cotangent is going to be adjacent over opposite. Now let's complete this triangle here. That's going to be 2 squared plus the square root of 3 squared is equal to C squared. So 4 plus 3 equals C squared. C squared equals 7, which means C equals the square root of 7. And that means that we should probably multiply everything by the square root of 7 here to find a triangle with equivalent ratios here where the hypotenuse is not going to have a square root in it. So that's going to be 3 times 7 is 21, and this is going to be 2 root 7. So it's all about proportionality here with trig values. So we can multiply by any scalar multiple and not change the proportions of the ratios. So sine is going to be root 21 over 7. Cosine is going to be 2 root 7 over 7. And tangent is going to be equal to, let's use this one here, where I don't have that factor in both of them. It's going to be root 3 over 2. Cosecant is going to be the reciprocal of sine. So that's going to be root 7 over root 3. I'm going to have to rationalize that. Times root 3 over root 3 is going to be root 21 over 3. Right? And then secant is going to be root 7 over 2, hypotenuse over adjacent, and cotangent is going to be 2 over root 3, which is 2 root 3 over 3 once I rationalize. Okay. So we'll go on that horizontal side A, right? Yes. So a squared plus 2 squared is equal to the square root of 13 squared. A squared plus 4 is equal to 13. A squared is equal to 9, and A is equal to 3. So let's just work on this. Sine is going to be 2 over root 13. When we rationalize is 2 root 13 over 13. Cosine is going to be 3 over root 13. It's going to be 3 root 13 over 13. Tangent is opposite over adjacent is 2 over 3. Cosecant is root 13 over 2. Secant is root 13 over 3. And cotangent is 3 over 2. That's it for this video. We'll come back next time and keep talking about section 5.2. See you for the next video.